The uncommon elements in this list are rarely discussed outside of the scientific community. Almost all of the Earth's rarest elements are radioactive and have no useful application in industry or daily life. The majority of these substances are solely utilized for research purposes and don't even last long enough to be extensively investigated. Each element on the list can be found in nature or artificially in relatively modest quantities. Number 10. Neptunium. The majority of neptunium is created in nuclear reactors by neutron irradiating uranium. Neptunium is mostly a byproduct of traditional nuclear power reactors and has no industrial uses. Neptunium is only found in trace levels in the Earth's crust, and nuclear power plants produce about 60,000 kilograms of it a year as a byproduct. Nonetheless, neptunium is used as a precursor to produce plutonium and in radioisotope thermal generators to power spacecraft. As a result of transmutation reactions in uranium ores, a few naturally occurring isotopes of neptunium, a transuranic element, are discovered. This isotope costs $280 per gram and is used in equipment like neutron detectors. Number 9. Curium. Curium is a radioactive chemical element that is only created in small quantities each year. It is mostly used in space applications and devices such as heart pacemakers, deep space probes, and planetary surface rovers. In some of the locations used for the atmospheric nuclear weapon test, trace amounts of curium have been discovered. Curium is moving towards a price per vial strategy. The majority of clients currently pay an average price per vial of about $625. Number 8. Americium. Another entirely artificial and extremely rare element is americium. This element has never been proven to exist naturally, hence it is produced in nuclear reactors by neutron bombarding uranium or plutonium. About 100 grams of americium are found in a ton of spent nuclear fuel, and several kilograms are created each year for use in neutron sources, industrial gauges, carbon monoxide detectors, and other practical and scientific purposes. Americium oxide used in smoke detectors costs around $1,500 per gram. Number 7. Californium. While the majority of transuranium elements are only used in research, Californium has a wide range of applications. The majority of these applications take advantage of a particular californium isotope's ability to emit neutrons. One of its principal uses is nuclear reactors reactivation. When alternative radiation therapy fails to work, californium neutrons are utilized to treat some cervical and brain tumors. This element is difficult to obtain and rapidly degrades, with only a half gram being produced annually, making it the most expensive metal on Earth, with its price increasing to almost $2.7 billion for 100 grams. Number 6. Promethium. The majority of the naturally existing promethium can be obtained in uraninite ore deposits, similar to Protactinium, which is also included on this list. The Earth's crust contains only 500 to 600 grams of promethium at any given time. The byproducts of uranium fission are used to produce synthetic promethium. A small amount of promethium is utilized in specialized atomic batteries. However, it is primarily only used for scientific study. They are useful in guided missiles and radios and are about the size of a drawing pin. Number 5. Protactinium. Protactinium has high toxicity and is extremely radioactive. Protactinium is naturally occurring, although it is primarily recovered from spent nuclear fuel. Protactinium can only be generated in the quantities of 125 grams at a time, with concentrations in the Earth's crust normally being a few parts per trillion. Outside of scientific research, this element has no practical use, but since it is one of the rarest elements, it can cost around $280 per gram. Number 4. Francium. The last element to be discovered naturally rather than through synthesis is francium. There haven't been enough francium collections to result in a substantial solid or liquid, but is thought to be a very reactive metal. Nevertheless, while its current applications are limited to scientific research into the chemistry and atomic structure, francium can cost up to $1 billion per gram because naturally occurring francium decays quickly. Number 3. Berkelium. Berkelium is a radioactive element that is metallic and silvery in color. The chemistry of this element is explored to a limited extent, and several compounds have been made. It was likely that berkelium had already been synthesized in earlier nuclear tests before this element was discovered. Just slightly more than 1 gram of berkelium has ever been produced in the United States since its discovery due to how difficult it is to make. Although it is not frequently used outside of scientific research, this element is used as a component in the synthesis of heavy elements like tennessine. The actinide berkelium can cost up to $27 million per gram. Number 2. Oganesson. Only a few atoms of Oganesson, one of the rarest synthetic elements, have ever been created. The radioactive substance has a very low half-life of about 0.89 milliseconds and is exceedingly unstable. The Oganesson was synthesized in 2005, despite the fact that its presence had been predicted back in 1895. Due to its extremely low and expensive extraction as well as its rapid decay, no characteristics of Oganesson or its compounds other than their nuclear properties. It is currently only utilized for research. Number 1. Astatine. Astatine is the rarest naturally occurring element in the Earth's crust, occurring only as the decay product of various heavier elements. In addition to being scarce in nature, Astatine is also challenging to make, even in its most stable form. The heat of its radioactivity would instantly cause a pure sample of astatine to evaporate. As it is so uncommon, no costs have ever been documented, and it is not accessible to the general public. This substance is being studied for use in nuclear medicine and may one day be used in targeted alpha particle therapy.